Now we are discussing about linear variable differential transformer. In this transducer, we have transformer. You see, this is a core material, iron core, soft iron core we are taking. It is a ferromagnetic material. And this is primary winding. In center, we have shown the primary winding. These two are the secondary windings. Left side one secondary winding S1 and right side secondary winding S2. That's why this is called as a transformer. Another way of representing the same thing, this is the primary winding. These two are the secondary windings, ES1 and ES2. This is the iron core. This is a differential transformer. Why we are calling this as a differential transformer? Because the output is nothing but the difference of the voltages of two secondary windings. The voltage across this secondary winding is ES1. The voltage across the secondary winding is ES2. Output is ES1 minus ES2. These two secondary windings are connected in series opposition. You see, this is connected in this direction, this is connected in this direction. So the output is ES1 minus ES2. Linear variable differential transformer. When we are varying this core to the left or right, accordingly the voltage across the secondary windings S1 and S2 vary. Hence the output changes. Sir, for what purpose we use it? We use it for the displacement measurement. Now we will try to understand the working principle of the linear variable differential transformer. Initially, when the core is at the center position, the voltage across ES1, the secondary windings S1 and S2 are same. So the output is ES1 minus ES2 equal to 0. When the core is moving to left side, now the more magnetic flux lines are linked with the ES1. Even though it moved towards this, because of the induction, there are less number of magnetic flux lines are linking with ES2. So the voltage across ES1 is higher than the ES2 when the core is moving to the left side. So the output voltage is in phase with the ES1. Similarly, when the core is moving towards the right side, now more magnetic flux lines are in link with the ES2 compared to ES1. So the output voltage across ES2 is high compared to ES1. The output voltage is in phase with now ES2. This is how LVDT is working. This is the graph. Displacement we have shown. For the right side displacement, the voltage you can see positive axis. For the left side displacement, the voltage is negative. Okay, because ES1 minus ES2 we have shown. Okay, means for the displacement with the different directions, the curve we are seeing, this is a linear curve, displacement versus voltage. What are the advantages with it? For a displacement of 4 millimeters, it will give a very quality output in the terms of the voltage. And this is having very high resolution. Even for a small change in displacement, it will give the output voltage such that we will come to know it displaced from this point to this point. Mainly in jet engines control, it is very much useful to us. When the jet engine is displacing from this point to this point, we should know that small variations, it is very much used in controlling of jet engines. And whenever we want to measure the material thickness, this duster thickness, we can use the LVDT. And for low frequency vibrations, when we want to measure, we can use the LVDT. It is having lightweight. LVDT equipment is very lightweight, small, and it requires less power. But the disadvantages are, because we are using transformer, windings, sometimes it produces stray inductance effects, unwanted inductance. That will affect the output voltage. That is one disadvantage. Second one is, it is not vibration proof. Example, if you have kept this, if you are keeping this device in a moving vehicle, then the output may vary. That is one disadvantage. And it is not temperature proof. When the temperature is changing, the output may change. And the output power which we are getting, the voltage is very much less. These are some disadvantages of the LVDT. Principle is simple. Primary winding to secondary windings. When the core is at center, output voltage is 0. When the core is moving to left, ES1 is greater than ES2 and the output is in phase with the secondary transformer 1. When the core is moving to right side, output voltage of secondary transformer S2 is greater than S1. ES2 is higher than ES1 and the output is in phase with the secondary winding transformer S2.